you. Okay. All right, so now we are on note sheets 4.4, which is on the back of 36. Now, kids, it is absolutely 100% necessary that you get this graph down. This is the regular sine curve. And you'll notice in letter D, we're going to do something to the sine curve. And if you look on the next page, we're going to do lots of things to the sine curve. You must have this one absolutely memorized. So what you do, you know what the sine looks like. It's one of your BFFs. It's one of the BFFs. We learned about that way back in September or August or sometime. It goes up one and down one. And this picture represents one complete cycle of the curve. After that, it just keeps doing the same thing. So we only graph one hill and one valley. That is an entire cycle. It's once around the circle. It's 360 degrees. So you are going to sketch from 0 to 360. What would this label have to be then? If that's 0 and that's 360, what's that one? 180. And what's this one? 90. And this one is 270. This is your starting point for all of the sine graphs we're going to do in this section. This is what we start with. The basic curve you already know. The labels make perfectly good sense, I hope. As you go around the circle, they're the quadrants. 90, 180, 270, 360. Okay? Now that's your sine. Now your cosine, and you got to memorize this one too. Your cosine, excuse me, thank you, is essentially the same, but you'll recall it does not go through the origin. So the cosine starts up here at the top of the hill and ends at the top of the hill. It is the same thing. It looks a little odd, but if you were to continue it, do you see the waves? But when you graph it, you go from top of hill to top of hill. This is still one revolution. It's 360. So right here in the middle, think about it. You have hill to hill. The middle would be the bottom of the valley. That's 180. And this one's 90, and this one's 270. That's what you have to have memorized. That's going to be the starting point for everything that we do in terms of cosine. And then one more. Now the tangent is brand new to you because it's not a BFF, right? The tangent has an asymptote at negative 90 and an asymptote at positive 90 and goes through the origin like that. So it looks like your cubic function. If you remember your BFFs at all, it looks like your cubic function. Everybody good? That's the starting point. Now, so those first three, put stars by. Those are the foundation. Everything builds off of that. So now we're going to do a sine picture. I'm going to try to squeeze it in up here so we can keep our sine right here. We're going to do a sine picture. The difference is it's 2 times the sine. Now, does anybody remember from earlier in the year what happens when we put a multiplier out there in front? Do you remember? Makes it taller. So instead of the hills going up 1 and down 1, we're going to have that same picture, but they're going to go up to and down to. So you're going to have exactly the same picture. This is still 360, 180, 90, 270. That is not changing. The only thing that's changing when we put that number out in front is it gets twice as tall. Morgan?
Do you have to label that every time?
You do. And when we start making changes this way, those labels will change. But as long as all we're doing is stretching it up higher, those labels will stay the same. 90, 180, 270, 360. Okay? Now, let's look at E. I'm going to squeeze E in right here. Now notice, E is a cosine, so the very first thing I do is focus on this. That's what it's going to look like. I've times it by 3. So that means my hills and valleys are going to be up and down 3, right? Tell me about that negative, though. What is that negative going to do? Do you remember? You used to know. It's going to what? Flip it. It's going to make it upside down. This negative turns it upside down. Very good, Joseph. We're going to miss you so much. Now, if I turn it upside down, then instead of starting at the top of the hill, it's going to start at the bottom of the valley. So that picture is going to start down here, it's going to go up and make its hill, and then end down there. Now, I don't know if you were listening to Morgan's question or not, but Morgan said, do I have to label this every single time? And my response was, yes. But the good news is, as long as we're just stretching it and doing stuff to it vertically, these labels are always going to stay the same. So it's going to end at 360. That's the bottom of the valley. It goes from bottom to bottom. So that's 360. The top of the hill would be 180. And the crossing points, the zeros, would be 90 and 270. Everybody good on that? So, you gotta remember stuff we learned before. Negatives turn you upside down. And whatever number this is out here in front, that's how much you're changed vertically. So if it's a 2, we're going to be twice as tall. What if it were a 1/2? We'd be half as tall, right? Okay. All right, now we're going to do a tangent, all right? I'm going to try to squeeze it in right here. Look at the tangent graph we're doing. It says negative tangent. All right, so we just talked about it. What's that negative going to do? Flip it over. So you're still going to have an asymptote at negative 90 and an asymptote at 90. But instead of the curve going up, it's going to be flipped over, so it's going to come down. I don't have that memorized. I figured that out because I know what this looks like. This is my tangent, this is my starting point. And I know that the negative out in front of it turns it over. So far, so good? All right, so now we're going to change some other stuff here. So this next one's a sine, so I'm going to go ahead and leave my sine graph here, but I'm going to erase these. You have them written down. And we are going to sketch y equals sine 1/2 x. Now, see where that 1/2 is? That's in a different place. If it's out here in front, we know that changes these labels, right? When it's on the X, it changes this way. Do you remember what it does this way? Jonathan?
It's a fraction, doesn't make it.
It does, because what we're going to do is we're going to take our normal ending point, and for the sign, what is your normal ending point? 360. And we're going to divide it by that number. So we're going to take 360 divided by 1/2. Because like Jonathan said, it's actually going to stretch it. Because when you divide by 1/2, it's the same as multiplying by 2. So this is 360 times 2. So my sine graph is now going to stop at 720. It's twice as long. This number right here divides your ending point. Your ending point is supposed to be 360. Divided by 1/2 is 720. Now, that's going to change this. What's the middle now? Now it's 720, so the middle would be 360. And then the middle of that would be 180. And the middle of that is 540. Now, if it helps you, divide all of these by 1/2. That's basically what we did. Everything got doubled. So that became a 180, that became a 360, that became a 540, that became a 720. Okay, a couple more and we'll go to lunch, okay? Let's do the next one. It's a cosine. All right, so now I'm going to draw my cosine, my regular cosine one more time for you. This is on your paper. You already have this. That is your regular cosine. Now I'm going to sketch cosine 2x. Raven, can you wait just a couple more minutes? Okay, go. All right, cosine 2x. So what does that 2 do? It shrinks it this way, right? It divides it. So the normal end point for a cosine is 360. Where is this one going to end? 180. We got 180 because this number divides the end point. So, it divides all the points. So if that's easier for you, you can just go that way. It divides all of the points. So what's this first one going to be? 45? And then 90 and 135? What about these labels? What would these be?
1.
Those are still 1 and -1 because the only way I can change those is to put a number out in front, right? And I didn't do that. But when you come back from lunch, we're going to do both. We're going to put a number here and a number here and sketch them. Morgan?
How are you getting the numbers that are like in
Okay, there's 2 different ways you can do that. So you got the end. You know that's 180, okay? If you're going from top of hill to top of hill, the valley is going to be the middle of that. So if 180 is the end point, and the middle would be 90. And then everything is right in the middle of everything else. So if that's 90 and that's 0, 45 is like right in the middle. Now what else you can do is go back to the original. To get the 180, you divided that by 2. You can divide all of these by 2. And that will be another way you can get those numbers. Or over here, times everything by 2. Over here, we multiplied all of those by 2. Okay? So let me see when you come back. I'm a little bit late getting this sent off. Oh, actually, no, I'm not 2 minutes early. So I'll have you back here at, no, I'm a little bit early. 12:19. You're in your seat at 12:19. Chris, can you turn that off for me?